Right, in this video, we're going to look at simplifying some rational expressions. We're going to start with question 7. Question 7 has two monomials being divided. So I have 60 times x cubed divided by 12 times x. Now these are monomials, everything's being multiplied, which means everything's a factor, and I can cancel whatever has matching terms on top and bottom. We'll start with the numbers 60 and 12. They have a common factor of 12. So if I divide both of them by 12, 60 divided by 12 is 5. 12 divided by itself is 1. Next, I'll look at my x's. I have x cubed on top, x on bottom. Their greatest common factor is x. So if I take x cubed and divide it by x, I get x squared. And x divided by itself is again 1. Now all I have to do is multiply the terms that are left. I end up with 5x squared in my numerator, and my denominator is just the number 1, so I don't even have to write it. It's invisible. Let's take a look at question 8. Again, we'll start with our coefficients. I have a 70 in the numerator and a 100 in the denominator. Their greatest common factor is 10, so I'll divide 70 by 10, and I'll get 7. And I'll divide 100 by 10, and I'll get 10. Up next, I'll look at my a terms. I have a squared in the numerator and a in the denominator. Their greatest common factor is a. So I'll divide a squared by a. I'll have a to the first power left, and a divided by itself is 1. Up last, I'll look at my b terms. I have b cubed on top, b to the 6th on bottom. Their greatest common factor is b cubed. So b cubed divided by itself is 1. b to the 6th divided by b cubed is b to the 3rd. Remember, when we divide variables with exponents, we subtract the powers of the exponents. Now all I have to do is combine the numerators, multiply those together. 7 times a times 1 is just 7a. And then we combine our denominators. 10 times 1 is just 10, times b cubed is 10b cubed. Let's take a look at another simplifying problem that has binomials in it. In this case, I can still simplify this by canceling common factors, but before I can figure out what my common factors are, I have to see what my factors are. So I'm going to have to factor this before I can get started. So when I factor this, I will take a look at the numerator first. The numerator has a GCF of 2a, so I will factor out the 2a by moving it to the front and dividing both terms by 2a to see what's left. If I take 2a squared and divide the 2a out, I will just have a left. If I take 10a and divide it by 2a, the a's will cancel, and 10 divided by 2 is just 5. So there's my numerator. For my denominator, I'll do the same thing. I have a GCF of 3a, so that's what I will factor out to the front. And if I take 3a squared and divide it by 3a, I'll have a left. And if I take 15a and divide it by 3a, the a's will cancel, and 15 divided by 3 is 5. Now that I have this factored, all I have to do is compare the terms being multiplied. I can see that in the numerator and the denominator, I'm multiplying both terms by a plus 5. Those can cancel, and they turn into the number 1. I also have an a on top and bottom that can cancel and turn into the number 1. All I'm left with is the fraction 2 over 3. That's it, and it can't be reduced. We have one more one more simplification problem. Let's go ahead and take a look at question 10. Here we go. Again, I can't cancel common factors unless I factor. I can't cancel things I just see in the top and bottom because they're not being multiplied by the things next to them. So before I can cancel, I have to make sure everything that I've got in front of me is being multiplied, which means I have to factor. So for my numerator, I'll factor that by finding two things that multiply to negative 10, that add to negative 3. Those numbers are 5 and 2, and if I want my 3 to be negative, the 5 has to start being negative. So we'll go ahead and have our p's on top, and we'll put in the negative 5 and positive 2 that are my factors. And then we'll factor my denominator. And for the denominator, I'll find two things that multiply to the negative 2 at the end, and add to the positive 1 in the middle. That's 1p. Now the factors of 2 are 2 and 1, and if I want them to add to a positive 1, the 2 has to be positive and the 1 has to be negative. So we'll put our p's in the denominator, and we'll put in the 2, positive 2, and negative 1. Now all we have to do is compare the terms and see if anything matches. And I do have a p plus 2 on top and bottom that match. They're getting multiplied by the terms next to them, so I can cancel them. So all I have to do is cancel them out, replace them with a 1. The 1s will end up turning invisible when I take everything left over. P minus 5 times 1 is just P minus 5. And in my denominator, P minus 1 times 1 is just P minus 1. That's my final answer there. Let's go ahead and take a look at question 11 and 12. Questions 11 and 12 have to do with multiplying and dividing rational expressions. And all I have to do to be able to multiply and divide rational expressions is to simplify them first. We always want to simplify, just like in the last 4 problems. So in this example, we'd like to multiply these two fractions together, but they're far too complex to multiply right now. I'd like to make sure that they're as simple as possible before I multiply them together. And in order to do that, I want to see if I have any common factors. In order to do that, we have to factor. So we're going to start with the numerator on the left. We have to find two things that multiply to 10, that add to negative 7. Those numbers are going to be 5 and 2. And if I want them to be positive 10, they both have to be the same sign. If they're going to be negative 7, they both have to be negative. So my numerator is going to be x minus 5 times x minus 2. The denominator is already factored, x plus 3. There's nothing to really change there. Let's take a look at the numerator on the other side. 4x plus 12. I don't need to make a t-chart for that because I don't have x squareds anywhere, but I do have a GCF. That should always be the first thing I look for. My GCF is the number 4, so I'm going to factor it out of both terms and move it to the front of the parentheses. If I take 4x and divide 4 out, I will end up just with x. And if I take positive 12 and divide it by 4, I'll get positive 3. Now in my denominator, this is the last thing I have to factor. I have to find two things that multiply to negative 12 that add to 4. The things that multiply to negative 12 that add to 4 are going to be 6 and 2. They do have to be opposite signs. If I want the 4 to be positive, the 6 has to be positive and the 2 has to be negative. So in parentheses, we'll have x plus 6 and x minus 2. Now all I have to do is compare my numerators and denominators to see what cancels. But it's important to note that as soon as this multiplication symbol is here in the middle, it turns the numerator into one giant numerator because we multiply fractions straight across. It also turns the denominator into one giant denominator, which means I don't have to just cancel inside one factor. I can cancel across the multiplication symbol, any numerator with any denominator. So this x minus 2 can cancel with this x minus 2, and they can both turn into 1s. This x plus 3 can cancel with this x plus 3, and they'll both turn into 1s. Once I've done this, I have nothing else that's similar on top and bottom, which means I can go ahead and now multiply together my final answers. I'm going to have this x minus 5 and this 4 left in my numerator. And in factored form, I can write them as 4 times x minus 5. I don't even have to distribute them back together. In the denominator, all I have is x plus 6, so my denominator will be x plus 6. And that one is finished. Let's go ahead and take a look at my dividing problem, which is almost exactly the same. The only difference with division is before I start my simplifying and canceling process, I have to keep, change, flip. So we're going to keep the left side exactly the same. We're going to change our symbol from division to multiplication, and we will flip our second fraction upside down. So the x plus 1 times x minus 5 will go to the numerator, and the 5x plus 15 will go to the denominator. Now, all I have is a multiplication problem, just like my last problem. So now all I have to do is factor and see if anything can cancel before I actually multiply. So we're going to factor the numerator on the left. It is a difference of squares, which means I have x being squared in front and 3 being squared in back. So I'm going to end up with x plus 3 times x minus 3. In the denominator, I have to find two things that multiply to negative 3 that add to negative 2. Those numbers are 3 and 1, and if I want the 2 to be negative, the 3 has to be negative. So x minus 3 times x plus 1. On the other side of my multiplication symbol, the numerator is already factored, x plus 1 times x minus 5. And the denominator doesn't have any squareds in it, but it does have a GCF of 5. So we're going to factor the 5 out to the front. If I take 5 out of 5x, I just have x left. And if I divide 15 by 5, I have 3. Now again, I can look at my numerators as all one term, and the denominators as well. So any numerator can cancel any denominator if it matches. We have an x minus 3 here and here. They can turn into a 1. X plus 3 here and here. They can also turn into 1s. And an x plus 1 here and here. They can turn into 1s. The entire fraction on the left has turned into the giant number 1 divided by 1, which means all I'm left with for my brand new solution is x minus 5 in the numerator here, divided by this 5 that I had left over. And that's it. That's my final answer. In the next video, we'll look at adding and subtracting rational expressions.